So in the last class, we were doing gamma function, right?
Yes.
Yes, sir.
See, now if I ask what is the value of the integral 0 to infinity e to the power minus t to the power uh, say 3 by 2 dt. What is the value of this integral? So you may be thinking that we can apply integration by parts or we can apply substitution. So by integration or by parts or by substitution, it is actually impossible, I can say. You can try it, but if you apply gamma function, then finding value of this integration very very easier. So to apply gamma function, first of all, you have to see the limits. Okay, a limit should be 0 to infinity, and the form of the integrand should be e to the power minus t to the power something. Now you try to rearrange it in the form of e to the power minus t to the power something minus 1, right? Gamma alpha, what is the form of gamma alpha? 0 to infinity integration e to the power minus t to the power alpha minus 1. So try to write that exponent of t in the form alpha minus 1. So 0 to infinity e to the power minus t to the power what? Alpha, if I write alpha minus 1, then it is 5 by 2 minus 1, right? Are you getting?
Yes, sir.
Now
तो
it
मतलब
is,
अल्फा माइनस वन के फॉर्म में.
yes, to
Yes.
make it in the form of gamma alpha. Now you can write it. It is what? Gamma 5 by 2. Isn't it?
Yes, sir.
Now finding the value of gamma 5 by 2, it is easier. You can apply the properties of gamma function so that you can find the exact value. So,
Sir,
ha,
sir, how 5 by 2 minus 1, sir? 3 by 2, sir.
5 by 2 minus 1 is not it 3 by 2?
Acha, acha, yes, sir. Means you have converted into alpha minus 1 form.
Ha,
Okay,
that
sir.
form I have to convert now, because what is the definition? Definition of gamma alpha, you see.
Yes, sir, got it.
Now we can apply this property, gamma alpha plus 1 is equal to alpha gamma alpha. Okay, by applying that property, what will be the value? So can I write it as 3 by 2 gamma 3 by 2?
Yes, sir.
Then gamma 3 by 2, can I write it half gamma half?
Yes, sir.
Look, I am applying the property gamma alpha plus 1 is equal to alpha gamma alpha, this property. Now it is 3 by 4, and what is the value of gamma half?
Root pi.
Root pi. In the last class we have proved, right? Gamma half is equal to root pi. So ultimately that is the value of this integration. Very simple. So sometime it may be asked in the exam, find the value of this kind of integral, where you can convert the integration into a gamma function. Fine. Or sometimes it may ask gamma of some negative. Like if I ask what is the value of gamma of minus 5 by 2. So for that, which property you have to use? This property only, gamma alpha plus 1 is equal to alpha gamma alpha. From that you have to rewrite it. Actually gamma alpha is equal to gamma alpha plus 1 divided by alpha, right? So you think that minus 5 by 2 is your alpha. Then gamma alpha is equal to gamma alpha plus 1 divided by alpha, right? So by using that property, what I can write? Think alpha as minus 5 by 2.
Gamma of minus 3 by 2 by minus 5 by 2.
Minus 3 by 2 divided by minus 5 by 2. Right. Now again apply the same formula for gamma minus 3 by 2. Now you assume alpha minus 3 by 2. Then
Minus 1 by 2.
divided by minus 3 by 2, right? Isn't it? Look how far I have to continue, unless that gamma of something, that something should be positive. So again you think alpha minus half.
Gamma of half.
Gamma half divided by
15 by 8.
minus 5 by 2 minus 3 by 2, and for this step minus 1 by 2. Now it is positive. Now we know the value of gamma half. It is root pi, and divided by it is what? 15 by 8. So I can write this. Do you get it?
Yes.
Sir,
Yes, sir.
excuse me, sir.
Yes.
Sir, can you explain from that second star that gamma minus 5 by 2?
Okay. I am applying the second formula, this one. Okay.
Yes, sir.
So you assume alpha is equal to minus 5 by 2 in that formula. Then what will be the right side?
Yes, sir. Minus 3 by 2.
Okay. So next step, again you apply the same formula for gamma minus 3 by 2. Okay. Means alpha is equal to minus 3 by 2. So it will
Sir,
be
my
what?
question is, my question is that why we have to assume minus 5 by 2? Why a negative sign?
Look, it is a problem. I told that it may be asked in exam, find value of gamma minus 5 by 2 or gamma of minus any other value. I am showing how to evaluate gamma of some minus value. Okay. For example, I have taken gamma of minus 5 by 2. You get it or not?
Yes, sir. Yes, sir.
Or sometimes it may be asked what is gamma of minus 11 by 2. Or it may be asked what is the value of gamma plus 11 by 2. But you think if the form of alpha is not something by 2, okay, then we will not get a proper value of gamma. To get a proper value of gamma, that gamma alpha means alpha should be something by 2 form. Means if I ask find gamma of say 2 by 3, okay, it will be difficult. Because we don't know how to find gamma of 2 by 3. There is no proper formula. For that we can apply some other properties of gamma, but in that way, means ultimately converting to gamma half, it is not possible. You cannot convert gamma 2 by 3 into gamma half by applying gamma properties. Similarly, gamma of minus something 3 by say 7. What is the value? These are very tough actually. So only this type of question may come whenever alpha is something by 2 form, minus of something by 2 or plus of something by 2. Okay.
Yes, sir.
What is the value? Again, I'm asking another one. What is the value of integration 0 to infinity e to the power minus t to the power 7 dt? Can you tell me?
Gamma of 6.
Gamma of
6.
6. Think. If you think this as alpha minus 1, then what is alpha?
Sir, 8.
8.
8.
Yes. 0 to infinity e to the power minus t to the power 8 minus 1. Then it is gamma 8. And it is integer. So finding value of gamma 8, it is
7 factorial.
what? 7
7
factorial. Yes. 7 factorial. Okay. Okay. Now let us come to यहाँ पे शायद एक mistake है. It will be root pi. Fine. This one. Is not it? Gamma half root 5 na? Okay, now another special function which is beta function. So in beta function there are two parameters m and n. In gamma function we have seen it is of one parameter alpha, but beta is a special function having two parameters m and n. So what is the function? The notation is beta mn and it is defined as the integration 0 to 1. Here the limits for the integration 0 to 1. Okay, and the integrand is t to the power m minus 1, 1 minus t to the power n minus 1 dt, provided m and n greater than 0. Okay, so here in beta function m and n should be positive and it is defined by the integral 0 to 1 t to the power m minus 1, 1 minus t to the power n minus 1 dt. You have to remember that. The form of gamma alpha, it is 0 to infinity integration e to the power minus t to the power alpha minus 1 dt. So ये beta function का that is the form. Now how to find value of beta something comma something? So there have a relation by knowing the value, by knowing the gamma function only you can find beta something comma something. So the formula is beta mn is equal to gamma m into gamma n divided by gamma m plus n. Okay, it is an important property or you can say important relation in between beta function and gamma function. Beta of m comma n, it is m. Beta of m comma n, it is equals to gamma m gamma n divided by gamma m plus n. Now some other properties you can see. That is also another important property. Beta mn is equal to beta nm. Means actually beta function is commutative. Means if you think m is equal to n and n is equal to m, both the values are same. Okay. Beta n comma m and beta m comma n both are same. So beta function follows commutativity property, we can say. And this is another important property of beta function which is used to find integration of trigonometric function sine and cos. Okay, so how to use it I will show you. The formula is beta mn is equal to 2 into 0 to pi by 2 sine theta to the power 2m minus 1 and cos theta to the power 2n minus 1. Okay, so that beta mn means beta function can be related to trigonometric function sine and cos. That is the formula. I think all of you have seen this type of problem in 10 plus 2 level. 0 to pi by 2 sine to the power say 10 theta d theta. Have you seen this type of problem? Whenever power of sine or cos it is large. Have you seen or not?
Yes, sir.
Or it may be sine to the power 10 theta cos to the power 8 theta d theta. This type. So we can solve this type of integration by using beta function easily. Fine. So it is important, it is another important property. Beta m is equal to 2 into 0 to pi by 2 sine theta to the power 2m minus 1 cos theta to the power 2n minus 1. And these are also some useful properties, but not needed now. Now let us see how to use or how to find beta function, beta values. So if it is asked, find beta of 1 by 2 comma 3 by 2. What is the value? So by integration, means by the definition, it is difficult to find. But by the property, beta mn is equal to gamma m into gamma n divided by gamma m plus n, you can find it easily. So what is the, according to the formula, as I told, that is gamma half gamma 3 by 2 and it is gamma 1 by 2 plus 3 by 2 means 2. Okay. So gamma half means root pi and gamma 3 by 2 means what? Half gamma half, right? Can I write gamma 3 by 2 is equal to half gamma half? You apply the property gamma alpha plus 1 is equal to alpha gamma alpha. I am not getting any response. Do you get it? Gamma 3 by 2, it is a half gamma half. I am using the property gamma of alpha plus 1 is equal to alpha gamma alpha, where alpha is equal to half. So it is what? Gamma 3 by 2 value, it is 1 by 2 into root pi. And what is the value of gamma 2? Factorial 1.
So 1 factorial.
That means 1. So it is pi by 2. Okay.
Yes, sir.
Now see another property I am showing. Find the value of 0 to pi by 2 sine to the power, let me think, okay, take anything. Say sine to the power 5 theta cos square theta d theta. Okay. Now you just compare with this form. So integration 0 to pi by 2 sine theta to the power 2m minus 1 cos theta to the power 2n minus 1 d theta. It is equals to what? 1 by 2 beta mn. 1 by 2 beta mn. So you need to know what are the values of m and n. So 2m minus 1 is equal to what? According to the problem, 2m minus 1 is equal to 5.
Yes, sir.
And 2n minus 1 is equal to
2.
2. Therefore, what is the value of m?
3.
3. And n?
3 by 2.
3 by 2. Now, according to the property, I can write it is 1 by 2 into beta 3 comma 3 by 2. Can I write this? The second property, according to the second property. These two, in the left it will be 1 by 2. 1 by 2 beta mn. Okay. Now how to find the value? You apply the property, another property again, beta mn is equal to gamma n divided by gamma m plus n. So gamma 3 gamma 3 by 2 divided by gamma 3 plus 3 by 2. So 3 plus 3 by 2 means 9 by 2. Now separately find the values. Gamma 3 it is factorial 2 and gamma 3 by 2 means half gamma half. So 1 by 2 into root pi. Now you find the value of gamma 9 by 2. It needs some time. Gamma 9 by 2. What is the value of gamma 9 by 2? Gamma 9 by 2, you think it as gamma alpha plus 1. So what will be the value of alpha? 7 by 2. Right? Gamma 7 by 2 plus 1. So it will be 7 by 2 gamma 7 by 2. Then gamma 7 by 2, it will be 5 by 2. Gamma 5 by 2. Then gamma 5 by 2,
3 by 2.
Three by 2, gamma 3 by 2. And gamma 3 by 2 means 1 by 2 root pi. 1 half gamma half means 1 by 2 root pi. So I can write 7 by 2, 5 by 2, 3 by 2, 1 by 2 root pi. So these two terms eliminated, and it will be ultimately what? 16 105. Is it? Okay, 1 by 2 is there now. One more 1 by 2 is there. I missed it, I think. This 1 by 2. So 8 by 105. Am I correct?
Yes, sir.
So in that way you can find this type of value of this type of integral. If only मान लो कि here this term is not present, only sine to the power 5 theta d theta. In that case, what you will do? That means what is the power of cos? If it is not present, 0. So 2n minus 1 will be 0 then. So n will be half. Okay. If this term is not present, then 2n minus 1 is equal to 0. That means n is equal to half. So calculate it with n is equal to half, not 3 by 2. Is half. Similarly, if sine is not present, then m is equal to half. Is not it? Accordingly, you try integration 0 to pi by 2 sine to the power 11 theta d theta. Also you try 0 to pi by 2 cos to the power 25 theta d theta. Okay. Any doubt?
So in that case, we have to take m or n half.
Of course. For the first case,
Okay.
which term is not present?
Cos.
Cos. So cos to the power
n 2n minus 1
that would be 0.
Yes.
Cos to the, you think it as cos to the power 0. Therefore 2n minus 1 is equal to 0.
Then it equals that. Okay, sir.
Okay, now let us come to that Bessel equation.
Sir,
Uh,
so can you please share the Jamboard link again in the chat box because I got reconnected.
okay.
Say it, sir.
Shivam said, let's see.
Thank you.
Okay, I think I have introduced Bessel's equation, but I have not shown the solution procedure and all. So, what is the Bessel's equation form? It is x square y double dash plus x y dash plus x square minus nu square y is equal to 0, where nu is a positive real number or 0. Okay. Now, for that ODE, it is easy to verify that x is equal to 0 is a regular singular point. Is not it? X is equal to 0 is a regular singular point. So you write Px, what is Px? And you write Qx. Then you multiply Px by x and multiply Qx by x square. And these two should be analytic, right? At x is equal to 0 to be a regular singular point. So I think you can verify it. X into Px and x square into Qx, they are analytic or not. So here x is equal to 0 is a regular singular point. To solve the Bessel equation, basically we need that Frobenius method. Nothing new here. If it is asked to solve Bessel kind of equation, you have to apply what? Frobenius method. So in the Frobenius method, we assume that y is equal to m0 to infinity a mx to the power m plus r as a solution. Then we substitute y dash, y double dash. Okay, I'm not discussing that solution procedure again, because if I show this solution procedure, then it will take again a whole class to solve this equation. So I think you can do it, right? That solution technique that is similar to Frobenius method. So after simplification in Bessel's equation, you will get this kind of series lastly. So where you can separate x to the power r term, x to the power r plus 1 term, and the rest you can write as series. Okay, so that is the final form of the equation in terms of power series. Now you know that in Frobenius method there have indicial equation, isn't it? What is the indicial equation? Here, what is the definition? How to find indicial equation? I told by equating the lowest degree terms coefficient to 0, right? So what is the lowest degree term in that series? X to the power r, and coefficient is this. So if we equate it to 0, this is the equation, and always we know that a naught is not equals to 0. Therefore, this is the indicial equation, r into r minus 1 plus r minus nu square is equal to 0. Okay, and after comparing the other terms also, other terms coefficients, that is another equation, and it is the general equation, means that what recurrence relation. Okay, so you will get these things naturally. There are no separate technique for solving Bessel's equation. So first equation, that is initial equation, and after simplifying, what is the form of the equation? R square minus nu square is equal to 0, na? Isn't it? After simplifying equation number 2.
Yes, sir.
So always in case of Bessel's equation, the initial equation is of the form r square minus nu square is equal to 0. Means roots are what then? Roots are plus minus nu. Roots are plus minus nu. Means value of r plus nu and minus nu. So for plus nu we will get a solution, and for minus nu we will get a solution, right?
Yes, sir.
Now the second relation gives us the value of a1. Second relation tells that value of a1 is what? 0, isn't it? Because earlier we have not assumed that a1 not equals to 0. We initially assumed that a0 not equals to 0. a1 can be 0, and second equation implies that a1 is equal to 0. Okay, and that equation means equation number 4 here, it is the recurrence relation. So see, it is our initial equation and these are the roots. Now for r is equal to plus nu, I am going to find the first solution. Okay, for r is equal to nu, I am going to find first solution. Look, according to the root, means according to the larger root, we always find the first solution, right? Do you remember or not? In Frobenius method, I told that always find the first solution for the larger root. So in between plus minus nu, what is the larger root? Nu, because nu is the positive. Nu is positive. So plus nu, it is the larger one. So for nu, I am going to find the first solution, means y1. Now you put r is equal to nu in equation number 3, you will get the value of a1 and it is 0. And you put r is equal to nu in the equation number 4, you will get the recurrence relation. Okay. So that is our simplified form of recurrence relation. As is equal to minus 1 by s into s plus 2 nu is equal to as minus 2. Now by using that relation a1 is equal to 0 and the recurrence relation, can we conclude that all the odd term coefficients will be 0? Look, a1 0, right? Now if you put s is equal to 3, a3 is equal to something into what?
A
A1.
minus 1. A1.
A3 is equal to something into a1.
Yes, sir.
So a1 0, so a3 0. Therefore you put s is equal to 5. a5 is equal to something into a3. a3 0, that means a5 0. So by using a1 is equal to 0 and the recurrence relation, we can get all the odd term coefficients are 0. a1, a3, a5, a7. Therefore, only the non-zero terms are even degree terms, right? Now you just find a2. A2 will be coming in terms of a0. Similarly, a4, that you can write also in terms of a0. And finally, you can write the series. You can write the solution. Actually, here we have done some arrangement to find the Bessel function. Okay, but if it is only about the solution, then you just find A2, A4 and A6. Then you put it in the series, you will get Y1. We have written Y1 in some specialized form. Okay. So see, I'm not discussing how I'm getting the form Y1x. Actually, the solution, the first solution, that means Y1, after this rearrangement, after this modification, okay, after this modification, the first solution, Y1, it is called Bessel function. Do you get it? So, it is nothing but the solution. So, I told the form of Legendre polynomial. Do you remember?
Yes, sir.
Legendre polynomial. You may forget because it is a huge expression. So, like Legendre's polynomial expression, there have some expression for Bessel function also. So, we means in Legendre's equation, we got a polynomial, and we have multiplied that polynomial by some constant to get Legendre's polynomial. Okay. Similarly, we got a solution Y1, and in that solution we are putting some means we are multiplying, we are adjusting the coefficients by multiplying some constant. Okay, and ultimate the form is, that is important. Ultimate form is important. Okay, how I'm getting the form, that is not important here. Ultimate form of the Bessel function, it is important. So there are two cases actually for Bessel functions. Here I told initially in the Bessel's equation, nu is what? Nu is a real number which is positive or zero. Means nu is a positive real number or non-negative real number. In short, I can say nu is a non-negative real number, right? So we are dividing it, means we are taking two different cases, mu integer and mu not integer. Okay. So if mu is integer, we are assuming it as n. Mu, we are taking nu is equal to n whenever nu is integer. Okay. And in that case, the expression for Bessel functions Jnx, it is denoted as Jnx. That Jnx is what? It is actually the modified form of the first solution. Okay, that y1, modified form of y1. You have to remember the form of Jnx. It is x to the power n summation m0 to infinity minus 1 to the power m x to the power 2m divided by 2 to the power 2m plus n factorial m factorial n plus n. That is the formula. You have to remember it. Sometimes that x to the power n is multiplied inside, so it will be x to the power 2m plus n. Right? If you multiply it inside, then it will be x to the power 2m plus n. In that also you can remember. M0 to infinity summation minus 1 to the power m x to the power 2m plus n 2 to the power 2m plus n m factorial n plus m factorial. It is actually simpler than that Legendre's polynomial form. Is not it? The general term, it is simpler than the Legendre's polynomial. You remember it?
Yes, sir.
Just remind, then you You'll understand. Look, now uh, if you are interested in the derivation of this jnx, then you have to see the calculation. But normally in the exam, it is not a derivation of Bessel function. Okay, it is not us. There are some properties of Bessel function, like properties of Legendre's polynomial. We have seen various type of properties, right? So here also we are going to see various type of properties of Bessel function. So Jnx, it is one solution. Okay, means y1, what I told, Jnx, it is the modification of first solution y1. So Jnx is the one solution. Jnx is the solution y1. What about other solution? There are two solutions for second order ODE. Jnx, it is one solution. What about the other solution? That we will discuss in the next class. Do you get it? What is Jnx?
Yes, sir.
Jnx, it is the notation for Bessel function, and it is the infinite series this, and which is nothing but the solution, nothing but a solution of the Bessel's equation. And this solution is called, or this function is called Bessel function of first kind of order n. Okay, there are second kind of Bessel function also. That Jnx, it is called Bessel function of first kind of order n. Okay, that's all for today. So it is your task to verify how this Jnx is coming. You can check it. Look, it is not for exam, for your clarification. How I am getting y1 and y12 Jnx. If you have some doubt, then you can ask me in the next class.
Yes, sir.
I am taking attendance now. Look, it is the last part of this power series solution, chapter 5. There are some properties of Bessel function, and then we are done with this. Response quickly. 742,
Yes, sir.
44, 45,
Present, sir. Sir,
46.
40.
Sir, 44 present, sir.
Okay, 46, 47,
Sir, 47 has written on chat box.
okay, 48.
48 sir written on chat box.
Why are you writing in the chat box?
Mic glitch, I think so.
I can see one or two from the chat box, but if it is more than that, then it is difficult. Okay, 749,
Present sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57, 58,
Present, sir.
61,
Present, sir.
63,
Present, sir.
64,
Present, sir.
65,
Present, sir.
66,
Yes, sir.
67,
Present, sir.
70, 71,
Present, sir.
Present, sir.
72,
Present, sir.
73.